Hey guys, this section is going to be about the slope and equations of parallel and perpendicular lines. So let's just do a quick reminder here. What do you recall about the slopes of parallel lines? So parallel, again, means that they will go on forever and ever and never actually intersect, okay? So which means if we're thinking about the slope of those parallel lines, means the slopes are going to be the same. So the slopes of parallel lines are always equal to each other. Okay, and then perpendicular lines means that we are going to have two lines that meet at a 90-degree angle. Okay, they might meet like that, they might meet kind of like this, but they are always going to be at the 90-degree angle. So if you notice, like in this example over here, we have one that has a positive slope, it is going up, and the other one has a negative slope because it is going down from left to right. So we know that the signs of their slopes are going to be opposite. And then there's one other piece of information that we need to remember also. So the slopes of perpendicular lines are opposite signs. So if one is positive, the other one will be negative, and reciprocals of each other. And remember, a reciprocal is just the flip of a fraction. So if I gave you a slope of 2/3, we could also write 2/3 like this instead of right next to each other. If we are talking about the perpendicular slope, that means that it's positive 2/3 right now, which means our perpendicular slope would be negative, and it would be the flip of our fraction. -5, remember, if there is nothing under the fraction there, there's a 1, which means if we had a -5, our perpendicular slope would be the opposite sign, so it's going to be positive, and it is going to be 1/5 because we would have the reciprocal. A couple more examples here. Again, when I typed it into this program here, it was -5, 6 next to each other. I like to think of it as -5, 6 written that way. It is -5, 6, which means our perpendicular slope is going to be positive, and it's going to be the flip of 5/6, which is 6/5. Okay, so let's kind of keep moving along with that idea. And just a reminder, we did some of this at the beginning of the school year, but just in case we have forgotten, we're still working with slope, which means we are going to be finding the slope given a graph, or we might be finding the slope given 2 points. So if we are given a graph, remember all we have to do is count, and we are just going to count rise over run. And a reminder that rise over run, if it is going up, it's a positive rise. If it is going down, it's a negative rise. If it's going to the right, it's positive. If it's going to the left, it's negative. So if we go from one point to the next, if we start down here at this guy, and we are going to this point, remember we rise first, so that means we're going to go up and down first. So in this case, we are going up, which is a +2, and then we are running this way, which is +1, 2, 3, 4, 5, 6. So our slope is we rise 2, run 6, which is going to be 1/3. This guy over here, if we go from this point to this point, our rise is up and down, so we are going to go down to here until we're even, 1, 2, 3, 4, 5, which is -5, and then we run in this direction, 1, 2, 3, 4, 5, 6. So our slope is going to be -5/6. All right, so happy day. We are not going to actually do this slide just because of the sake of time. We're going to practice finding slope through 2 points multiple times and on a graph anyway, so we are not going to practice it on this slide. Okay, so how about if I am given 2 points? Okay, so if I'm given 2 points, that means I have 2 xy's. So I'm going to have x1, y1, that's like ordered pair number 1. And then I have x2, y2, which is ordered pair number 2. And if we want to calculate our slope, we are going to subtract our y's. So we are going to go y2 minus y1, because y, remember your y-axis is your up and down axis. And remember when we did slope, we did rise, which is up and down, and then run. If we did y2 minus y1, we need to do x2 minus x1. So you do need to make sure that they go in the same order when you go to calculate. So let's take a look at what we have here. I have ordered pair number 1, that's going to be x1, y1, and ordered pair number 2, x2, y2. And if we use our formula in the top, we are just subtracting our y's. So I'm going to go y2, which is 3, minus y1, which is 6. And then on the bottom, we're going to have x2 minus x1. So be careful here because it's minus negative 2. So you have to be a little bit careful here. So that would be 3 minus 6 is negative 3. And then in the bottom, 9 minus negative 2 is 9 plus 2, which is 11. Okay, and then just practicing it one more time. Why don't you pause the video, calculate your slope, and then start the video and check to make sure that you're right. Okay, so when you do this, make sure that you label your x's and your y's. Your y's on top, we had negative 1 minus negative 4. Again, be careful with that. Negative 1 minus negative 4 is negative 1 plus 4, which is 3. And then 5 minus 0 is just 5. Okay, so now what I want you to do is practice that again. Again, I'm not going to go through all of these individually. I would like for you to take a minute, calculate the slope of each line, and then look at those slopes and decide if they are parallel or perpendicular. Okay, so they come in pairs. Okay, and oops, I'm not going to have enough colors there, am I? I have to go back up to gray. Okay, so if I look at, I'll do the first one, and then I want you to go back and do the other two. So line 1, I've got 2 ordered pairs. I've got x1, y1, and I've got x2, y2. So essentially we are finding the slope of 6 lines. So we have to do this 6 times. So this first one here, my y's, if I subtract them, I've got 4 minus 0 over 7 minus 1, which is 4 over 6, which is 2/3. So the slope of that gray line there is 2/3. If I look at the next one, I've got 6 minus 0 and 3 minus 7, which is 6 over negative 4, which is 3 over negative 2. And if you notice, those two slopes are reciprocals of each other and opposite signs, which means these two guys are going to be perpendicular to each other. Okay, so pause the video, take a minute. I want you to actually practice finding the slopes of these. If you don't practice finding the slopes, then you're not going to be mastering that skill. So please take a minute, stop the video, find the slopes of these other 4 lines, and decide if they are parallel to each other, if this blue and green are parallel, perpendicular, or neither, and then if the yellow and gray are parallel, perpendicular, or neither. Okay, so take a look, see if your answers match what I have. This middle group here, the green and the blue, they had a slope of 5, 6, and 3/4, which are not equal. They're not opposite reciprocals, so there's no relationship between those slopes. And then our last one is we have the yellow line has a slope of negative 2/9. The gray line also has a slope of negative 2/9, which means they have the same slope, so they are parallel. Okay, so now we're going to do a little bit of algebra here with it, and we are going to remember how to use slope-intercept form. Remember, slope-intercept form is in the form y equals mx plus b. So y is just our y value of our coordinate on any point on our line. X is the x value of a point of a x value of the point on the line. M is your slope, and b is your y-intercept. Okay, so what we want to be able to do is write an equation of the line that goes through this point and is parallel to this line. So what that means, if we look down here at our directions, slopes of parallel lines are the same, but have different y-intercepts. So they have different values of b, which means everything in our original equation is going to be the exact same. The only thing that should change when the lines are parallel is our value of b. Okay, so what we're going to do is we're going to substitute the values of your slope, x and y, into the slope-intercept form. And then you need to figure out what your different b is, and then write your equation with the same slope and your new value of b. So we have, here is our slope-intercept form for our original line. I have an x and I have a y that it's going through. Keeping in mind this is going to change, so that is just going to be b. Okay, so we need to find a different value for b. So I know that it is parallel, so therefore my slope is going to stay the same. I have an x value that I know, and I have a y value that I know. So if we do a little substituting, instead of y, we're going to put in 1. 2 is the same because the slope is the same, times -1 plus b. 1 equals 2 times -1 is -2. If we add 2 to both sides, we get that b equals 3. Okay, that's part of our answer. It says write an equation of a line, which means we need to be in slope-intercept form, which means we need to go back up to this equation, and it's going to be the exact same. We're going to have y equals 2x. That doesn't change. Remember, the only thing that's going to be different is your b value, which we just found, which is 3. So if we graphed this line and this line, which originally, remember our original equation, it's kind of hard to see in here because it's all erased on there, but our original equation was y equals 2x minus 3, which means if we graph them both, they'd have the same slope. One would cross the y-axis at +3, and one would cross the y-axis at -3. Okay, let's try that one more time together, and then I'm going to have you do the second one on this slide by yourself. So we have y equals 2x plus 2. That's our original equation. I'm just rewriting that on my paper, and I know that I'm going to have y equals mx plus b. And my ordered pair that I'm using is x, y. Again, this 2 is the only thing that's going to change in my equation, so I need to figure out what that new value is going to be. So instead of y, I'm going to take y out, and I'm going to put 3 in its place because I've got a 3 right up here. So I'm going to have 3 equals 2, and instead of x, I'm going to put a 2 in there. Plus, I don't want my b to be 2 anymore. I need to figure out that new value of b. So I need to actually substitute b in there because I need to know what that value is. So we have 3 equals 4 plus b. If I subtract 4 from both sides, I get -1 equals b. Again, our final answer should look just like this one, y equals 2x, plus instead of 2, I should have -1. So you could also write 2x minus 1. Okay, so go ahead, pause the video, see if you can do the next one on your own, where you're going to find a new value for b using your x and your y and your same slope. Okay, so go ahead and check, see if what you got agrees with what I have. Hopefully it does, and if not, go back and double check your work. Okay, so now we are going to do the same thing, except this time we want our lines to be perpendicular to each other, which means we need to remember that the slope of a perpendicular line is the opposite sign and the reciprocal. So those two things have to be true. So once we figure out the slope of the perpendicular line, all we have to do is the exact same steps that we just did. So my original equation that I have given up here is y equals 2x plus 5. And I have the ordered pair 4, 3. I'm just rewriting that from the problem. Okay, and I know if my slope is 2, right? My slope is m here, which is 2. That means my perpendicular slope is going to be the opposite sign, so it's not positive, it's negative, and it's going to be the reciprocal, which is negative 1/2. So the slope that I am using from here moving forward is negative 1/2. I am not going to use 2 anymore. So I'm going to say y equals, oops, I don't want y equals because I'm going to actually substitute my values in there. So instead of y, I'm going to put 3. So y equals, again, I am using my new slope of negative 1/2. My x value is 4 plus b, because I need to find the new place where it crosses the y-axis. So I'm going to have 3, negative 1/2 times 4 is negative 2 plus b. If I add 2 to both sides, I get 5. So my final answer in slope-intercept form is y equals my perpendicular slope, which is negative 1/2 x, and then my new y-intercept, which is plus 5. Okay, just like the other one, I'm going to do one more with you guys, and then I would like you to try the last one on your own. Okay, the line perpendicular, so my original slope was negative 3, which means the slope I'm going to use is positive 1/3. Okay, because if there's nothing in the denominator, there's a 1. So if we flip the reciprocal of 3, it's 1/3, and currently it was originally negative, so our new slope is positive. I have an x and I have a y. So I'm going to say y equals mx plus b. Again, I need to find a new value of b because I don't want 5. I need to know where that perpendicular line crosses the y-axis. So I'm going to have negative 4 equals 1/3 times 6 is 2 plus b. If I subtract 2 from both sides, I get negative 6 equals b. So there's our 2 pieces of information that I need. I have my slope and I have my new y-intercept. So I'm going to have final answer, y equals my new slope, my perpendicular slope was 1/3, times x, my new y-intercept is negative 6. So go ahead, pause the video for just a second, and try this last one here down on your own, and then come back and double check that you were right. Okay, hopefully you noticed that you also got negative 2x minus 1, because our slope started at positive 1/2. The reciprocal of 1/2 is 2, and the sign opposite would be negative, so we have the slope of negative 2, and then we substitute our x, y, and our m in there, and find that our y-intercept is negative 1. Good luck.